Good afternoon, everyone. You're welcome to today's class. In today's lesson, we are going to continue from where we stopped. You recall that we solved and arrived at these two equations. So, what we want to get is actually the moment at support B and the moment at support C. Of course, you know that the moment at support A and moment at support D is equals to 0. All right. Now, like I said before, we're going to use, as I said before, we're going to use determinant method to get the value of MB and value of FC. First thing first, what we need to do now is to get the determinant of the matrices of the variables here, which is this 12.725, then 4.1125, then we have 4.1125, then 60.45. All right, that's case one. All right, when you, of course, you know that this times this minus this times this. Okay, please, because the board is not wide enough, we are going to break it down. We have a 12.725 multiplied by 16.45 minus 4.1125 multiplied by 4.1125. Okay, now when you compute this, we are going to have compute that. We have 192.42. 192.42. All right. Now, in the same vein, we are going to solve for the determinant of MB. dMB is equal to. Now, in this case, you use the values at the right hand side after the equality sign to replace the coefficient of MB. All right. In this case, we are going to have 812.93. All right. Then 1423.41. Then this one still remain. The coefficient of MC still remain 4.1125. Then here we have 16.45. All right. Then you solve 812.93 multiplied by 16.45 minus, let's say, minus 1423.41 multiplied by 4.1125. All right. When you solve that, when you compute that, we are going to have 7,518.92. All right. That is for DMB. So we're also going to solve for DMC. DMC is equal to, now we are solving for DMC now. The coefficient of MB, you write them down, 12.725, then 4.1125. Then for the MC, you use the numbers or values at the right hand side after the equality to replace the coefficient of MC. This now becomes 812.93, 1423.41. All right, 41. All right. Now we now solve. All right. We now have 12.725 multiplied by 1423.41 bracket close minus 4.1125 multiplied by 812.93. All right. When you compute that, what will you have? What will you have? We have 14.769.72. All right. Now we're almost there. We are not done yet. Now we now need to calculate for our MB and our MC. How do you get that? From here, you now have that MB is equals to DMB MB over D. The determinant of uh, MB over this D, then MC also will now be DMC over D. All right. Now, because there's no space, I'm going to have to clean this. All right. Now, of course, say MB is equals to DMB 7518.92. All right. Over what is our D? 192.42. If you compute this, what will you have? If you compute that, I'm going to have 39.01 kilonewton meters. All right. The same thing, MC is equals to DMC. All right. DMC is 14,769.72 over 192.42. All right. This one will give me, if you compute this as well, you're going to have 76.76 kilonewton meters. All right. Now we have gotten the moment at support B and the moment at support C. The next thing to calculate is our free span moment. All right. From here, let me write this one down. The MC, let me write it here. MB is equals to 39.01 MB MC is equals to 76.76. Okay. I'm going to clean the board right now. Okay, because we are still going to make use of these values when we are computing for the free span moments. All right. Now, because of time, I will end here today. In our next class, we will continue from where we stopped. Now, for those saying this is mathematics, you could say that this mathematics, yes, there are things that's related to mathematics here, all right? But this is not actually mathematics. We are trying to analyze the building, all right, to know the reinforcement to be used in a particular structural member. It's not mathematics per se. We are analyzing a structural member to know the sizes of reinforcement bars to use in that structural member. We are talking about, if you have been following me, we are talking about beam 1 in our design that we have been analyzing all along. So this is beam 1. All right. The span is 2.250, 4.1125, 4.1125. So at the end of the day, this is the moment that we now use, to compute, to know the size of reinforcement that will be adequate in this on this the structural member. All right. So we are working towards that. So we are done with the support moment right now. The next class we are going to work on the free span moments. Then the free span moment here, you know that WS square over 8 is our moment. All right. WS square over 8, WS square over 8. But in this case, when you want to get the actual moment, all right, you now add, the result you get from your free moment, you subtract it from support moment divided by 2. So in our next class, you will get that. Thank you very much. All right.